Okay, hello everyone. Thank you for joining me. We are in San Diego C++ Meetup number 54, if I'm counting it correctly. Today is September 12th, 2023. We have a special guest today, Chris McArthur, and I'll present him in a second. Just before we go to the main course, just the regular housekeeping. We are looking for speakers. If you have anything to present, anything that from just a lightning talk to something bigger, let me know. Just uh, ping me on Discord or Twitter or anything. I'll be more than happy to host you. Uh, any subject would be great. Usually, if you learn about a subject and you just happen to create slides along the way, you'll be able to be an expert in this specific domain, and you can share that with others. So that's basically the idea. Meetup fees are sponsored by Qualcomm wireless R&D software. I'm part of Qualcomm, not part of the wireless R&D, but part of the cloud. Thank you, Charles Bergen, for sponsoring the Meetup fees and your continued support. So thanks a bunch. We have the Dropbox link for all of our sessions. The recording are in the San Diego C++ Meetup YouTube channel, but the slides can be found in the Dropbox. Let me know if you can't access it. Ask me for a link for Discord, and I'll let you. I'll provide you the new link. It's expiring every so often. So the San Diego C++ Meetup YouTube. This is where I uploaded my recording. So usually within a day or two, the recording would be uploaded. San Diego C++ Meetup handle is on this slide. I also have my own Twitter handle, Kobe_CA. No more than that. No Mastodon. Like I have Mastodon, but I'm barely there. There is a page that I'll post a summary of the meetup notes, and also sometimes, if I have time, I'll post something new regarding C++, just a blog post, so you can browse to this link to see all the previous posts that I had. This is part of Martin Warburg blog page. Without further ado, let's present the main theme for today. Hey, Chris, thank you for being here, and thank you for presenting Conan today. So Chris McArthur is a Conan developer advocate. He's been given to the open source community with exploit database containers, C++, CMake build system maintenance, and other open source software projects for nearly 10 years. He began his career as a C++ developer and has since then added other languages, including Go and TypeScript, to his skill set. Prior to joining the Conan team at JFrog, he previously worked in the video broadcast and mobile advertising industries on a variety of projects. His diverse experiences include blockchain, low-level hardware networking, distributed system security, and cloud-native DevOps. As a developer advocate for JFrog, Chris deals with Conan. Chris shares his deep knowledge of DevOps and package management to the C++ community globally. Welcome, Chris.
Thank you very much for having me.
So I'll stop sharing. Glad to have you here. So it's all yours.
Awesome, thank you. I will share my screen. All right, do you want to get in on this? No. Sorry, dog wants the attention as well. Here's me talking. All right, so can you guys see my screen?
Yeah.
Perfect. So as Kobe introduced, I'll be giving an introduction to package management Conan 2.0. This is going to be an introductory presentation, so if you're familiar with Conan, a lot of this is going to sound familiar. However, I'm really going to be focusing on a lot of the new workflows that you can do with 2.0. So even if you are familiar with Conan, you might still learn something. So that's my thing for you. So I've been using Conan for almost 4 years now. And I like to say that I've been opening enterprise issues for Conan for the past 3 years. And you can go click on the link and see those. I included all my socials as well. I have started a YouTube channel recently, and I've been working on migrating one of my larger cloud applications to Conan 2.0. So I'm focusing more on the DevOps side of things and building out a more complicated CI/CD pipeline for C++. If you want to get a hold of me, you can see all of these on the list. My name on the internet is usually Prince_ChrisMC. So what is Conan? This is a question I get asked far too often, unfortunately, but it deserves a good answer. And it's a C and C++ package manager. See, a package manager in any ecosystem is to make your life easier by installing dependencies. Conan in particular, it's open source, distributed, scalable, flexible. And one of the key selling features is that it supports all the different types of build systems, whether it's CMake, Maison, AutoTools, the list goes on. Works for any platform. If you're cross-building to embedded, targeted hardware, or Android or iOS, you can do that as well. And it's really more than just a CMake. So the thing that really distinguishes Conan from the other package managers, there are others, competition is healthy. It enables you to build and distribute binaries. So we offer JFrog's Conan Center, which has over 1,500 open source projects, and they're built in over 100 configurations. And that just helps show you the kind of scale that you can reach with Conan. So today we're going to be building a small application. It's a GLFLW OpenGL with moving particles, some logging for some math, unit tests for sanity. So you can see at the bottom left-hand corner, there's a cute little fountain that's going to be spewing water particles that are going to roll on the floor. And that's what we're going to make today. I'm not going to focus too much on the coding side of things, more of the building and packaging, but it should be, it's a good example for a type of application I think most of us would work on. So our theme this year with Conan is to keep it simple. And there's nothing more simple than making a hello world app. So that's where I'm going to start this off today. Creating a new project, it's pretty easy. You only need to define one file with a main. We'll need to build it, and we'll need to take advantage of the library to handle a lot of the formatting. So build scripts is a good place to start because every C++ developer likes dealing with those. So this is a very simple CMake list.txt. I know a few months ago you guys had another talk about CMake. I like to take a more simplistic approach. I always find the less is more. So you can see here, we have our CMake minimum required. We define our project. We have dependencies, right? So we're calling find package for speed log. We're adding an executable, and we're linking the two together. And when you're working with Conan, your project should build perfectly fine without it. And the reason for this is because we really focused a lot on the transparency. So whether or not you're using Conan or not, you shouldn't be locked into the package manager. We have to also tell Conan which dependencies we want. So you can do that with a Conan file.txt where you have a requirements. We're going to be requiring speedlog. It's one of my favorite libraries for formatting. And we're going to be using version ranges. These existed in 1.x, but in 2.0, they're a lot more powerful. So you can see here, we're going to take anything greater than or equal to 1.10, but less than 2. And we're going to have some generators. We're going to use CMake Toolchain, CMake Depths, as well as a layout for CMake. And to build our app, it's pretty easy to get started. We clone the repo, we switch into it. It's Conan install, and then CMake preset Conan release. And Conan will generate the presets for us. Conan file is the best place to start. Whether you're doing a complicated app or a simple one, it's really the best place to start. A lot of people have been saying that you have to use a Conan file.py. It's totally wrong. It's a misconception that's been spreading a little bit, but you heard it here first. You can use a Conan file.txt, especially with 2.0. You have a lot of features that you have access to with this. And what Conan is going to do behind the scenes, it's going to build a dependency graph. And with 2.0, we introduced this notion of transitive dependencies. So our app is going to explicitly require speedlog, and it's going to pull in whatever version's the latest. When I wrote this slide, it was 1.11.0. And speedlog, that recipe is actually going to contain a requirement to FMT. And for instance, 10.0.0. But our app will also gain that requirement. It'll be a transitive requirement. And by default, Conan will keep all the transitive dependencies private. So you won't accidentally use or include headers or libraries that you didn't mean to. And this really helps you prevent making mistakes where perhaps a certain symbol shouldn't be exposed or leaked into your application. You can make sure that's correctly hidden. One safety measure to be less error prone for developers. We're going to have to set up our IDE. So I'm going to be using VS Code with the CMake extension, again with the presets. So after we do our Conan install, we're going to be able to just configure selected presets, and we're going to be able to pick our Conan release. And it makes it really easy to get started. And I have a demo. So if I switch to sharing VS Code, boom. So this is our sample little project. If you notice the little cute graphics, we have a source directory with a main CPP, really difficult, hello world. And we have our CMake list.txt. And it's very simple. And then we have our Conan file.txt. And this will help set everything up. So if we do Conan install, whoops, with our nice dot at the end, Conan will go down and search the internet. I have everything locally to keep this nice and quick. Did I scroll too far? So you can see here, it found all the references locally in my cache. Why is, oh, I'm scrolling to the wrong place. All right. You clear your console, but it didn't clear, unfortunately. So you can see here, it found everything locally. So right now it's using speedlog 1.12, and that satisfies our version range, as well as our FMT being greater that's required. So it downloaded the packages and built them, and it generated the files for us. So inside of our build folder, and this is defined by our CMake layout, we have build release generators, we have our CMake presets, we have our CMake toolchain file, and you can notice all of the targets that we're going to be required to find. So if I go back to my README so I can copy my commands, we can configure CMake. And we can build as well. Now, if I want to do this with the IDE, I need to reset so that it loads my presets. One of my tips for everybody is when you should always do your Conan install before you open your IDE. This will make it easier for the IDE. A lot of them implement caching so that they don't constantly research your index or your local source code. So I had to reset mine, but now it gives me the option to pick the Conan release. And you can see while it configures, it found all the targets and found everything correctly. You can build, and here we already have VS Code selected our app, and then I can just click the little play button, and this will run our app. And this prints the same message we had in our main. Easy, simple. We didn't have to worry about downloading and installing FMT, despite the fact it's a requirement. The only thing we had to do was list speedlog. And this is really where the power of a package manager comes from. Going back to our presentation. So hello worlds are nice. They're a great way to demo some of the basics, but at the end of the day, we all have to implement business logic. Most of us are developers by trade. So we're going to be making a small room that has a fountain in the middle that's going to spew particles. And for this, we're going to have to make a couple changes. So we're going to be editing the main file to add our business logic. We're also going to have a header file to define what a particle is and some of the operations we're going to do on it. There's going to be some physics calculations we're going to implement. And then our CMake list and our Conan file.txt are going to have to change. We're going to have to pull in a ton of more dependencies. So if we were to update our CMake list and our Conan file.txt, you can see they grew quite a bit. But in particular, we're adding a lot of dependencies. So the order is not particularly important. I just threw them all in. And you can notice we also have to link these against our app. Now, the GLFW, if you notice, it doesn't have a CMake namespace, right? It's just GLFW, where all the others have a name : prefix to it. And this is because Conan actually can mimic the CMake targets that would be installed had you installed it from source code. So this is a really easy way to make sure both your project would work with and without Conan. However, this isn't always true. So if you notice some of these other ones like glad and linmath.h, these don't actually support CMake. So what we're going to end up getting is the default names that Conan's producing, and this is the same name as the recipe. So in our Conan file.txt, it's the same name, just : name twice. Special note though for linmath.h, that .h is generally not recommended. A lot of build systems have problems with special characters, so the more simplistic the name, the better. So installing our new dependencies. So previously, our instructions looked like this. We did a clone, Conan install, and then we hit the configure CMake with our preset. Now they look like this: Conan install and configure CMake. They're the same. And this is really where you start to see the power and flexibility of a package manager start to shine. Despite adding all of these libraries, as you're going to see, there's quite a few system dependencies as well. All of this is managed by Conan, and it's all going to be easily made available for us. So when we install new dependencies, we'll need to make sure to reconfigure CMake. And we're also going to want to develop and debug our application. So we're going to have to make sure when we do our Conan install, we're going to install for both release and for debug. And in my Conan install, there's that little ampersand : build type. That ampersand means the current reference. So that means because I'm using Conan file.txt, it's going to be my local project is going to be in debug. And all the rest of my dependencies will be in release. I know a lot of these libraries are really high quality, well-maintained libraries, so I'm not particularly worried about them having bugs, and I'm not going to waste my time rebuilding them in debug each time. So we're also going to be launching the debugger. So we're going to create a VS Code launch file, and we're going to be able to step into our application and test that out. So another demo for you guys. Stop sharing. And we'll share VS Code once again. Adding particles. So our VS Code, we have our launch debug, and this is pretty easy. We're just going to point it to the build folder to debug our app. It's just as easy as that. We're going to rerun our Conan install. And this will update all the dependencies we need for release. And then we can also run this for debug. Build type equals debug. The default that I'm running is release, which is why I have to specify debug on the second one. Now I can go and I can change my preset to Conan debug. And this will reconfigure CMake. And I can build our app. And if I go to the run and debug, I should already have some breakpoint sets. Oh, I don't, but I will add one for us. Now, when I go to debug, I can really easily just run and debug our app. And now we can see here we hit our breakpoints. I can disable this and let it run. This way Mac will let me grab my window and we can see our fountain spewing particles now. And it's really that easy. We can go back in, we can enable our breakpoints, and we can go through and see all the different things that are going on. So this makes it really easy to work and manage your dependencies without really having to go through a lot of them. So we can calculate our time, our matrix, and we can work through some of the math here. And then we could inspect and run just as you normally would, whether or not you're using a package manager, which is the seamless experience you're hoping for and expecting. So with the presets, it makes it a lot easier to have access to this. And that's just as easy as you want it to be.
So Chris, you had another window with the actual particles showing when you
didn't get to see it, did you?
No.
Let me thank you for pointing that out. Does this have permissions? Yes, it does. I guess it doesn't capture it as some of the other ones would. So I will run this again. Disable my breakpoint and let it run. We can see our particles are finally here.
Mm-hmm. Beautiful.
So it's a small little physics thing where we're just calculating the trajectory and the velocity of the vectors. Nothing too complicated. And this lets it work. So right. So we started adding our business logic, but we're smart developers. We're going to add some test code. This is one of the fundamental basics that you should do. And doing this in Conan is a little bit different. You have to explicitly say, I want to add my test requirements. So our particles are experiencing a force, and this is really easy to test. It's just basic math to make sure that they're working. So we're going to be adding our tests, and then we're going to be modifying our build scripts and our Conan file again. So to pick a testing framework, I went on to the Conan Center website. Just a small disclosure, we're working on this in real time, so it might look different, and we're going to change it pretty quickly as we're developing it again. But we're going to pick this one, and not just because it's the first one, but because it's the first one. So we're going to update our Conan file.txt. You can notice here we're going to be adding our test requires for gtest. We're going to pick something greater than 1.14, which is the latest. And we're going to be doing less than 2. It's always a good practice not to pull in the next major version, because that means there's breaking changes, and that means that you likely need to update your code. So it's a easy protection just to say less than the next major. And pro tip, keep your version ranges simple. You can write complicated expressions, Conan will let you, but less is more in this case. Oh, I had an arrow for it, perfect. So that's what we're going to be adding to our Conan file.txt. And we're going to do some bonus. We're going to have to refactor our CMake. And the reason for this is because I want access to our particles header file, and I'm going to make an interface header only library for CMake. And by doing this, and then again linking it in the app, it'll give us access to use this for our actual tests. So I like to keep things simple, so we're just going to use ctest, and we're going to use its built-ins. So again, you can see that call to find package where we're going to be requiring it. We're going to include Google test and gtest add test at the bottom so that we can automatically load all of the tests that we're going to be running. So this is a really easy way. ctest gives you a lot of built-ins for enabling and disabling tests, and Conan actually supports this. So inside Conan, there's a configuration that you can change to skip testing, and we'll be able to take advantage of that later on. So we're going to be adding some new steps. We're going to be building, and we're also going to be calling ctest. But before we install our dependencies, there's one more thing we need to get to, and we got to take in some of our DevOps and reproducible builds. So we're going to take advantage of lock files, and these were completely reworked with Conan 2.0. And they're a mechanism to achieve reproducible builds across dependencies, even when new versions or revisions are introduced. So there's a one-time setup for this, Conan lock create, pretty easy. And then to update them, it's Conan lock create, lock file none, and then update. And once you create the lock file, the default name is conan.lock. It'll automatically get picked up each time we call Conan install. So why does every package manager support this? When you're talking about package management, whether it's NPM, Cargo, Golang, they all have their own version of this. And it's pretty easy. So the way Conan works is inside of our recipe or Conan file.txt, we had a list of requirements. And what Conan's going to do is it's going to resolve that against the known space of available packages. And it's going to pick the best one, and it's going to give us our reference graph. Now, do packages really exist? Yes, but no. And should you rely on them? Probably not, but you could. It's kind of dangerous. And the reason this happens is if we take our example for app example, or we take our example of app, we have our speed log version range. Now, that requires FMT, and that has another version range that it can possibly accept. So what's happened today is that when we resolved, we took speed log 11, and that's what our app is pinned against. And then we got FMT 10.0, and that's what our app is pinned against. Now, eventually this changes. And there is an FMT 10.0 that gets introduced. And this is a malicious supply chain package that's trying to steal your secrets. No shout outs to Victor or the fact he might work for a company named Meta, but you never know how this might happen. And what happens then with Conan is because our version range in this open space of packages, it'll resolve against that and it'll pick the best one. So our reference graph will now have an app, speed log, and then that malicious package of FMT. And this is a really bad situation to put yourself in. And it doesn't need to be a malicious package. This could be anything from an API change to a broken release. If you haven't tested it, you don't want your CI to randomly start failing because someone else did something on the internet that you had no control over. So what lock files do is it removes the available space. And what we end up getting is a list of known good packages. And then when Conan goes to resolve which references to pick, it'll pick one that you've already tested that you've known is good. So you can update your lock file locally, you can update it. And then only if you decided that's good, you can save that and push it so that everybody else will be benefiting from those. And that list of known packages is what we'll build against. So time for another demo. If I share my VS Code once again.
So Chris, a quick question. This is new in 2.0, the log file that is. Is it new or we had it in 1?
We had lock files in Conan 1.x. However, they were very different. The Conan 1.x lock files were the entire binary graph, and that had a lot of trade-offs and consequences. So it wasn't as easy to use them as it will be in 2.0.
I see. And this would, when we decide on a specific log file content, you said we should version control that so everyone else can benefit. This would be part of the root tree repository or a subdirectory, or it doesn't really matter.
It would be next to your Conan file.txt. So
got it. Okay.
Great question. The way Conan 2.0 works is everything is relative to your Conan file. So there's no absolute arbitrary paths. So when you're working on a given project, you always want to think of that project in the context and what's surrounding the Conan file.txt.
Okay.
Yeah.
Okay, thanks.
So if we go to our testing and log files, we can see that over here. So we have in our root folder structure, we have our Conan file.txt with our list of requirements. And one thing that's fun to note is for speedlog and gtest, I decided to use version ranges, but I did not for the particle demo. The reason for this is some of these libraries don't actually have releases. For example, Tiny C thread hasn't been updated since 2016, and it's never had a release. So there's not really a way that you could say or describe to pull in the latest version of this. And the same thing's true for LinMath. For GLAD and GLFW, you could add version ranges. I just didn't have the experience with these libraries to decide what the safest range would be for them. So if you have any input or you use these libraries for a long time, please let me know. Our Conan file.txt. This here is again next to our Conan file, and you might notice there's a few extra names in this one than before, right? So something like Xorg system and OpenGL system weren't necessarily in our Conan file.txt. That's because these are transitive dependencies that are being pulled in. So you can see those are included in a lock file and being pulled in. I don't have any Python requires or build requirements, but the exact same logic would work on those as well. So if you note here, the speedlog version is actually different than what we've been getting when I have been doing my installs. So the last time I did Conan install, we had speedlog 12. That's the latest version. But my lock file, I'm actually going to pin it down to an earlier version. The reason for this is because I made this demo before some of these versions were released. So my lock file just predates when these libraries were released. And when I do Conan install, because I already created the lock file, I don't have to create it again, we'll be able to see which versions it's being pulled in. So if I get to just the right spot, you can see here when I called Conan install, it actually tells you that it's using the lock file. So this is a super easy way as a developer to make sure it's working. You can see it. And when we get down to our requirements, you'll actually notice our speed log is the exact same version and revision that we had in our lock file. And the same is true for FMT. It's the 811 or 811, I apologize, and that's here. Now, this list is also different than this list. If you have a keen eye, you'll notice Xorg isn't actually in the list of requirements. And the reason for this is because I wrote some CI/CD scripts, and I've been running these on Ubuntu. So the Conan 2.0 lock file actually supports multi-config or multi-platform lock files. So this exact same lock file will work both on Ubuntu and the Mac OS that I'm using to do the demo. So one of these libraries pulls in Xorg as a transitive dependency, but only on Linux. And that was something that wasn't possible before with the old lock files. So with that done, all of the rest of our commands would still work the same. So we could still build and debug as always. So if I change this back to release, I can let this build. And that's pretty easy. So that is, oops. And then I can come here. We can run ctest. So you can see here in my test results window, and if I go down to testing, I have a few extensions installed. It actually detects the tests. However, Conan doesn't generate the test preset that the IDE is expecting, so we're going to have to run this locally. And we can do that because I saved the instructions in the README. So we're going to output our results, and we're going to save them in a JUnit XML test. This is a standard format, and if we want, we can upload this to a server later on if we wanted to do something more complicated. So running this, oops. Could not find executable. Oh, because I built the wrong one. So if we go for tests, we can add our particle test executable. I can build this, and now CMake will have built it. I can then run my command, and this time it works. Perfect. So we have our new tests. We have our particle test. This is a very terrible example of a unit test. But when we initialize a particle, they should be active and they should have 1 unit of life. And when we run our tests, we can actually see that being done. And if I refresh, we should have our results. We do not. Is it inputting in my build folder? It did. So here we can see we have our results, and we can see our 1 test passed and failed, which is nice and easy. Now, what we can also do is make sure we can update our log files. So we do Conan lock create. We can do lock file equals none. So this is going to ignore the one that I already have, and then I can say update. Oops. Current directory. So this is my Conan file.txt, and now it'll go and look and search. So you can see it's searching a bunch of different remotes. It found a few of them, and now it's going to update our lock file. So if we take a look at our lock file, we can do so in our diff. Now, because I have multi-config and I only ran update on my current profile, some of them are going to get dropped, but we can see speed log over here. That's being updated from 110 to 111. We can see the OpenGL system, that one is gaining some timestamp and references, which we're missing, which is perfect. And then FMT is also being upgraded from 8 to 10. Now, it's not safe to just upgrade, so you always want to make sure to build it. So we're going to rebuild our application, which it didn't do because I forgot to run Conan install. So now when we used our lock file, we're going to see that it's pulling in those new files or new revisions. So we have our lock file, check. We can double check our requirements. These are the new ones, which is perfect. And now when I ask it to build, it'll reconfigure and rebuild. And it rebuilt our particle tests. So let's also build our app. And everything works. So we know this is safe and we can commit this changes. My favorite is bump deps. And you could commit this, save this, and move on. Alrighty. So we will go back to our presentation. So we started our development. We figured out our development process. We figured out the tools we wanted to use. Next, we got to make this distributable and share it. So in the Conan language, this is called creating a package. And what this will allow us to do is build and distribute the precompiled binaries and avoid some of those annoyings. Well, it built on my machine. I used to work on l'équipe process as an intern, and on the process team, it was really common for the other developers in the department to say, well, it built on my machine. Why doesn't it work on the build system? This is one of the things that's going to save us a lot of time down the road. So in order to update our build scripts, all we have to do is call install with our target, our app, and we have to say the runtime, which is our executables, will go into the bin folder. And it's as easy as that. You can get more complicated if you're doing something like a library. You could do the CMake config files. You don't have to, because again, Conan will generate those by default. If you're working exclusively in Conan, it's a convenient time save that you don't have to write the config files yourself. So we have our Conan file, and This is going to give us a recipe, which we can use to create binaries. And the instruction is Conan create. Now, a recipe contains the instructions for the reference. So that's our name and version. It also tells us how to get the source code, how to build it, and how to package it. So in order to help make this easier, we actually have something called the Conan extensions repo. And this is a collection of helpful tools to benefit all users. And the one we're going to focus on today is the convert txt to py. And this will take our Conan file.txt and convert it. And there's quite a few useful extensions that you have access to with Conan 2.0. One of them is called deployers. And we have a deployer, for instance, for doing a license bundler. So you can take all the dependencies in your graph and you can extract all the licenses for those, put them in a zip folder, because we all have to worry about the legal requirements when you pull in dependencies. And this is just one of those convenient nice to haves that most users will benefit from. And you can find a lot of similar examples in this extensions repo. So when we convert our conafile.txt to the conafile.py, it'll look something like this. And just doing a side by side so it's easy to see, you can see most of these things map over directly one-to-one. So in our Conan file, we have our DSL, and you can see here we have our class, we have a generators, which are the same too, they're just added. Our layout is the same. And then for our requirements, this is a little bit more of syntax, but you can see we're adding the exact same versions with the exact same version ranges. And our test requires, that one goes under build requirements. And next up, we have making the actual recipe. So this would still work exactly the same. These two files are equivalent, and they both would work with Conan install. This Conan file, though, needs a little bit more for us to use Conan create with it. So we have to add our reference information. So we're going to change this so that it has the name and version, and we're also going to tell it where our source code is. So we're going to export our sources from our local directory, and it's our CMake, our sources, and our test folder, and all of these will be copied into the Conan cache when we create it. Up next, we have the binary, and this is very simple for us. We only have an application, so you can add our package type. And then there's also our settings. And these things will come together to creating what's called a package ID. And this is how Conan knows which binary to download. And then lastly, we have all the instructions that we've been running locally. We need to tell Conan how to do this as well. So we need to add these to our conafile.py. And so for CMake preset Conan release, inside of our build method, we have to add our CMake helper, and then we have to call configure. For build, it's just cmake.build. For tests, this one has a little bit more fun to it. CMake test from the Conan build helper doesn't call ctest directly, so we have to tell CMake which arguments to pass, and I do that in the configure. There's more advanced workflows. You can always use self.run, and then you could call CMake ctest directly yourself. For CMake install, we didn't show this in a demo, but presumably we would have been able to do this. You can do, again, instantiate the helper and then just call CMake install. And these instructions map one-to-one just across. So creating our first package is as simple as Conan creates, and this will give us our app and our app1 binary. So our instructions for developing this locally haven't changed. They're exactly the same. So even though we've gone through all this work to get to the point where we have a conafile.py, if we wanted to develop this locally working in our ID, none of that changes. So the extra lift to teaching Conan how to use the Conan file is not actually any changes to the development workflow, which is a very seamless and easy experience. So for the last demo, we're going to call Conan create. And if I switch back over to our VS Code window, we're going to do create package. Oh, it's going to not like me. So now that we've gone over here, Our lock file is not updated, but we could very well do that if we wanted to. Here is our Conan file.py. This is what we call a recipe. And it's really the step-by-step instructions on how to get the source code, build, and package your recipe, right? And it's very similar to what we've done. So when I run in my terminal, Conan creates, this will work just as it always has. And it'll run through all those various steps. So if I make this bigger, I can share you some of the fun details. So this will look pretty familiar to what our install was doing. You can see here it's using our lock file. We have exporting recipe to the cache, and this is just copying all the files that we declared in our export sources, which is this line over here. And this takes our settings. I'm running on Mac OS. And then our requirements. These again match what's in our lock file. So notice I committed the changes for the update to our lock file in a different branch. Well, I'm not impacted here. And I still get to work with those old ones, even though that pesky past Chris was changing dependencies that he shouldn't have. And here we're going to find all our requirements. And you'll notice here our app is actually listed now. So this is the version and revision. And this here is going to be our package ID, this SHA that comes after. And this is taking into account all of our settings in order to determine this. Going down the list, we can see it installs our dependencies as it had done before. We can see it calling CMake configure for us now. Well, we no longer have to pass these instructions in. It finds all of our dependencies, links against them, and it builds both our app and our particle tests. And then we can see here when we call CMake build on the target test, we actually run our unit tests. And it's just that easy. And this will create and save a package that we can use afterwards. So if anybody else wanted to use this, we could very easily do something like Conan upload, and then we can say app 1.0, and this would upload it to a server. And then somebody else could do Conan install, and they could say install requires, and then we could say app/1.0, and then they would be able to install this version of our app and use it themselves. So that's how you could create packages that you can redistribute and share. So going back to our presentation one more time. So building our recipe in CI, this is something you can do as a next step. I have in my Git repo a full example of this working in GitHub Actions if you're curious, and you could do this yourself. So some of the things I didn't cover, which might be interesting, adding a test package, managing the profiles. I shared a little glimpse of what the settings were, but I didn't touch on them. Securing your build pipeline, always good to scan for vulnerabilities and dependencies, and making an installer with deployers, which I touched on as a feature. So if you're looking for more resources, Diego gave an amazing talk at CPPCon last year, as well as at ACCU, and this goes over all of the graph improvements in detail. That's probably one of the most important aspects of what's new in 2.0. There's a blog post. This blog will have all of the new features that have been highlighted, and there's quite a few. And in the last 8 months, we've done 10 releases, and every single one of those releases has new features as well. So we're constantly adding more and more things to it. So one of my favorite new features that I've been waiting for a long time that was finally possible with 2.0 was something called backup sources, where when you build your open source dependencies, you can automatically save the source code and upload them to an external server so you can have them available for yourself later on. And that was directly a business requirement that I had to solve with Conan in my past. So having that built in is just amazing now. The tutorial section is going to be your best friend. There are tons and tons of tutorials. This is just the second level of them. As you dig through each of these, you'll find even more. And this is the best way to learn. If you have questions, the GitHub repo for Conan is the best place to go. You can also get help on the CPP Alliance Slack and the hashtag include Discord. That's good for community help if you want to discuss and share ideas. I highly recommend doing it. So conclusion, pip install Conan. Go try it out yourself. It's very easy to get started, and I hope you enjoyed my presentation.
Thank you, Chris. Thanks a bunch. Are you open for some questions?
Absolutely, absolutely.
Okay. So let's let others to ask. I have few myself, but Todd.
Yeah, yeah. Thanks, Chris. Hope you're doing well today. If I can ask a naive question, that I'm going nuts with Ubuntu having older versions of things in Docker containers. So OpenSSL was the one today, but what does Conan buy me? Does Conan buy me something in trying to deal with some of these problems?
So it gives you control over the versions. So if I share my screen, OpenSSL in particular is one of these things that is super important. And I've recently had to work on migrating some of my other open source projects to OpenSSL 3. And there are some changes that happened, especially if you're using some of the deprecated APIs. And of course, we were. So if I grab OpenSSL, we can go and we can check the versions. Wow, this looks amazing. Oh my God, I didn't know this changed. This must have changed recently. So versions, you have the choice of installing whatever version you want, right? So if you want to install 3.1.2, or if you're still using 1, you get that choice and that flexibility. What Conan will do with its toolchain is it'll make sure that CMake is configured to pull the version that you installed with Conan. So it gives you that extra precision in saying, I want to use this. Even though Ubuntu and apt repos are changing dynamically, you can say exactly which versions you want to use. Hopefully that answered your question.
That's perfect. Thank you.
Chris, I have a few questions. Other people can stop me. So I have one. There's Ashish wants to have. So I'll start with. So the log file basically is not intended to be modified manually. There are tools. There are utilities to command line tools to manipulate the log file, right?
Yes, 100%. Definitely do not modify the log files manually yourself. Doing so, you'll miss information. So it's always recommended. You can do Conan lock add, and you can specify exactly which references you want to add. If you want to merge two of them, for instance, you ran your profile for Mac and you ran it for Linux, you had 2 lock files, you can merge those together as well. That is super duper important. Definitely don't modify them locally manually, because you'll get it wrong most likely.
Okay, thanks. Ashish.
Hey, so before I ask my main question, since we were talking about log files, do you know why it includes the timestamp? I haven't understood the reason for that.
The reason for that is because there might be a discrepancy between your local system and what's on the server. So there is a situation where if you're developing something locally yourself and you're working on a package, you might have created a few times and you might have populated your cache. However, when that branch that you're working on gets merged, you don't want to be using the local version you were developing. You want to pull the latest and best version, which is the one that was built by CI. So as a safety measure, if you forgot to flush your temporary ones, that timestamp will kick in and it'll know, okay, the one on the server is newer than the one you built yourself. I'm going to use the one from the server. Okay,
so that is used in package resolution. The timestamp is also consumed.
Yes, yes, yes.
Okay. Okay. Now for my other question. So you didn't cover this, but maybe you have some experience with this. Integrating a Conan package. Let's say you're building a shared library, and if you want to use CPack, to package your application, right? How do you get the Conan packages into, let's say you're creating an RPM or whatever your CPAC generator you're using? How do you get the Conan libraries into that? I've written hacky solutions where I go look up the imported location of the Conan targets and so on, but there's nothing that needs to be supported out of the box.
Well, let me show you what exists now. So if we go to our Conan extensions repo, there are already deploy. So the feature you're looking for is something called deployers, and you can create a custom ones for yourself. So are you crying? You're such a loud dog sometimes. Give me a second here. This guy's bothering me. Sorry about that. So you can see here, there's two of them that exist. I had mentioned the license one, but I also have a runtime zip deployer. So what this one is going to do is it's going to go through and find all of these shared objects that are inside of it, that are inside your Conan graph. So here I just did FMT for the README as an example, but like if we did this on the app we just made, it would find all the shared dependencies and it would give us access to those so that we can copy them. So just peeling back a layer, this actually gives you all of the dependencies. And then if they have a package folder, you can go through and you can say, I want to check in the binder and the libdir, and you can do whatever you want. So for this example, I'll make this a little bit bigger so you can read. I've just done it simply and I looked for executable files. So we have DLLs and EXEs for Windows. We have our dynamic libs for Mac. And then on Linux, it's anything that's executable. And this will copy everything into a folder and zip them together. And then you can easily work with this.
Okay. Okay. So then I would zip them and then unzip them, presumably, and let CMake deal with, or CPAC deal with them. Is that the intent?
You don't need to use CPAC. You can make the RPM yourself.
Sure, but that's what we use at work, right? We use CPAC, and I don't think I'm going to rewrite all that stuff. So let's say I do want to get it integrated into my CPAC code, into my CMake list, basically. Is there a better way? Is there a way to get this outside of the Python world? Somehow get this info out? I guess I could dump it to a file and read it or something from CMake.
Yes. However, if you're already doing your you're already doing CMake install, which is where your CPAC is probably being called.
Mm-hmm.
You could just run CPAC here, right? Like you'll have access to all of the artifacts that you normally would package with CPAC.
Okay.
And I would imagine you can just call CPAC here. I know some users have started playing with Debian packages, and there's I can't remember off the top of my head. There is a Debian tool to create packages, and it'll create all the basic files for you with the name and versions and whatnot. So they'll run that inside of their deployers. So this will give you access to all the binaries, and then it's free for all from there what you want to do and what you want to write.
And you wouldn't happen to know where I can find the code for this Debian thingy, would you? Because I could probably figure out the RPM way of doing it if I could see that code.
No, unfortunately not. I know the user was doing it for his work and he didn't share the code, and I didn't.
Okay. Well, this is promising though. Yeah, thank you. I'll look into this some more.
Cheers.
So Chris, I have a quick, I don't know if it's a quick, but if we need to introduce Conan to a existing repository that is using CMake, what is the laundry list that, so as a consumers of packages, there is also a side of producing and exporting let's say a library that other team can use, but as a laundry list would be, I need to pip install. Let's say I'm working in a container. Okay, so pip install of Conan is probably prereq for that. That's the first thing. But what do you see like out there in the wild? Do you see like all kinds of bootstrap scripts to execute the Conan commands? like the Conan install and all of that, or you think that users should just, let's say they clone a repository, let's say they have a virtual environment with pip install of Conan. Like, do you think that we should automate that part of Conan install, or they should do it manually?
It really depends on how much you're trying to take advantage of Conan. So if you need to manage your settings and you're trying to control which binaries are being pulled in, you're going to want to call Conan install, and you want to be able to specify your profiles. Perhaps there's conf for system tools or build tools. If you're trying to do that and managing your environment, Conan install is definitely recommended. However, there are other alternatives. So I didn't touch on this, but we have our CMake Conan wrapper. And for new in 2.0, we have CMake providers. And this is an extension CMake offers such that package managers can tap into the calls to find package to install dependencies. So if you wanted to have a minimal no bootstrap, the requirement would be to install Conan first. But once you have that and you had the CMake provider from Conan in your repo, you could easily call that and include that to download and search for your dependencies.
I see.
So I believe there's a few ways this works. It's either directly with the find package, but I believe you can also specify a Conan file.txt. And this would simply install with the settings that are detected by CMake, and then Conan install each of those that you need.
Okay, thanks. So we actually hosted Diego maybe a year or two, maybe a couple of years back, and one of the things that I remember, he showed um, a way to consume a package and also develop on the same package and maybe export that back. So this is the same. So the workflow that he described with Conan 1.0, is it different with 2.0? Like, because I do see a use case where I need to in the very near future, I want to have a library that I uh, I'll be exporting and also making some changes, then exporting that to the outside world.
So the nuance here is, are you simultaneously working on two recipes or not? So if you're working on your library and you're consuming, the recommendation is just to use the normal developer commands. So CMake configure, CMake build with your presets, and you're good to go. You don't have to worry about the rest. The only time you really need to call Conan create is in your CI. You really shouldn't need to use that locally unless you're testing changes to your recipe. Now, if you were developing two projects simultaneously, and one of them and both of them are Conan recipes, there's something called editable. And this is a mode you can put Conan into for a given reference to say, use the files that are local. So instead of using Conan create, you could do Conan install, Conan source, Conan build. And this would populate all the folders correctly. And once you put it into editable mode, you could then reference that from your other project. And you could say, use this reference in editable mode. And instead of getting it from your cache, it'll get it from your local working directory.
Got
I
it.
think that's
Okay.
more of an advanced workflow. My personal feeling is that if your code is so tightly coupled that you can't work on one without the other, you're probably better due to refactor your code so they're actually separate recipes. So generally, I don't think most developers are in that situation. I think just using CMake correctly and writing your source code as you normally would and checking it into Git and your source control for your pipeline to take over, more than enough.
I see. Yeah, I see what you're saying. I see what you're saying. That's true. Okay, thank you. Thanks. And the fact that basically CMake presets was introduced in one of the recent version of CMake. So this is probably kind of a baseline. Like, what happens if I use CMake that is predating the presets? Is this an issue?
No. So Conan 2.0 support for CMake starts at 3.15, and I think this is like 7 or 8 years old at this point. Presets, I think, were introduced in CMake 19 or 20. So if you're using something older than that, actually, the Conan presets that are generated are for CMake 3.23. So if you have something less than that, you could manually call all of the command lines. So when you configure CMake, instead of passing a preset, you could say CMake toolchain equals, and then it'll give you the path.
Yeah. Okay,
when
got it.
you install Conan, it'll actually spew out the commands for you both ways. So you can just simply copy paste the output from Conan install, and you can do it the older way or the new way.
Okay, and the default that you showed was released. This is something that was in your global profile. That's why it's being released.
Yes. So the default generated profiles, they're great for debugging and developing. The default is always released. So
Got it.
it's just an easy point to start.
Okay. Okay. Thanks a bunch. Thanks. Yeah, any other questions?
It looks like Todd has his hand raised as well.
Todd?
No, I'm done. I'm fine.
It is sticky bit, I think.
Okay.
Okay. So oh yeah, there is one. Okay, go ahead.
Hi, thank you for your talk. My name's Sale. I'm very interested in Conan, but I have a kind of like a different problem. So I work in or used to work in an environment where we cannot just go out on internet and get packages. So is there a mechanism in Conan that you can get everything, pull everything that you need and kind of freeze it locally or in a local machine or local environment, built environment? It's because you cannot go out and every time you need to build something, you need. It's very strict.
Absolutely, absolutely. My first job, the build machines didn't have access to the internet, so this is a long-standing thing in Conan. You have several different options here. You can have your own Conan server, so you can host everything locally, and you can have your own process that'll match your corporate rules for how you take things from the internet and bring them in and validate before uploading to that server that you have internally to have access. The other thing that you can do is you can actually install everything on one machine. With the deployer features, there's actually a built-in for this that's default in the client. It's not even an extension. It's called the full deploy, and this will give you an entire copy of everything you need locally in your current directory, and you can easily copy this onto another machine, and then you could build on that machine. So if you had a thumb drive, which I don't think I actually have one, unfortunately, you could sneaker net from one computer to the next. Actually, on this one, I believe I have a blog post that you would be interested in. So
basically, you build everything on your own machine, and then you're happy, and then you just push it up to your local Conan server. That's
yes.
That's the idea, or that's how you.
That's
okay.
That's generally what most people do. So
Okay.
you can set up servers so that they proxy Conan Center, for instance, or you could have a separate pipeline where you have a manual review process for introducing new packages. And
but you push them up. You push them up manually, so you know what you're pushing up to your local server, right? Sorry about that.
Most devs automate this process, but yes, it's whether you do it manually or automatically, you can make that decision to push them to your own local server.
Okay, thank you.
For the deployers that I was talking about, this is the blog post that I know was written exactly for this. So you can install your dependencies and copy them onto another machine is one of the use cases. So relocating environment shells files in Linux and Mac. So if you're curious, this is something you can do as well.
Thank you.
Thanks. Any other questions? Okay. Okay, so we'll wrap it up. Thanks, Chris. Again, it's super interesting. I'm personally very interested in Conan, using it as for a hobby, but getting more and more serious for that super soon. So thanks a bunch for that. I needed this overview. Anything else, Chris, from your end before we let you go? Thanks.
So we will be at CPPCon as well as meeting C++. If you're looking for more Conan talks, not all of our talks are going to be about Conan. We have a CMake modules, build system modules, C++ 20 modules talk at CPPCon, which will be very interesting.
Nice.
So you can stay tuned and follow us.
Cool. Okay. Thanks everyone. Thanks for joining us. Thanks, Chris. Have a great rest of your day.
Cheers. Thank you, everyone.
Take care. Bye-bye.
Thank you.